Hello, so my name is Andrea Sala, and I'm an intern at Welty Environmental Center in Beloit, Wisconsin. During my internship here, I've done a lot of research and data collection in order to develop a research project. And I was partnered with my friend Kate Kleinschmidt, who was working from Beloit Memorial High School, which is a high school in our area, and she was collecting data for our project and worked on research analysis as well. So our research project was comparing the water pH of rain and stream water at two different locations within the Rock River Watershed. Since Beloit Memorial High School is right on the river, Kate was able to sample the water there, while I was able to sample water at Big Hill Park, which was easily accessible in a short walk from the Welty Environmental Center. We had rain gauges set up at both locations as well so that we could test rainwater pH. The goal of our research was to see if the stream water pH would differ at both locations, as well as to see how rainwater pH would differ from the stream water pH. The two locations are very different since the Big Hill Park location has a large abundance of vegetation, flowers, plants, whatnot, while the Beloit Memorial location is really close to pavement and has very little vegetation. Um, our overall research questions were, do atmospheric conditions affect water chemistry? And how will the presence of vegetation affect stream water chemistry? So we were doing some rainwater research and some stream water research. Our research methods were relatively simple. We were collecting data consecutively over an 8-week time period, beginning in February and ending in April. We collected at least one time a week. We followed the hydrosphere protocol very closely. We used small containers to collect directly from the river, and we used the same pH meter to measure the pH levels of the water at both locations. And for the rain, it was obviously a little bit harder since it doesn't rain every day, but on the days that it did rain, we collected water samples from the metric rain gauges at both locations and tested those samples for their pH levels as well. The data collection process was very simple and not very time consuming, except for the days that it was snowing and really cold. Um, After completing our data collection, we began to analyze our findings, and we discovered that the rainwater pH was consistently lower than the stream water pH at both locations. We also discovered that the stream water pH at Big Hill Park was higher than the stream water pH at the high school. So after doing some separate online research of our own, we began to infer what the cause of our findings was. And we considered that the stream water pH at Big Hill Park may have been higher because of the presence of vegetation. So bodies of water can sort of act as carbon sinks. So obviously when plants perform photosynthesis, they sequester carbon dioxide out of the water, and this just leaves behind hydrogen, and the pH gradient itself is simply a scale measuring the concentration of hydrogen ions in the water. So as the hydrogen ion concentration increased, the pH was increasing at that location. As for the rainwater pH being much lower than the stream water pH in both locations, Kate and I came to a similar conclusion. We considered that the presence of air pollutants might have played a role in the lowering of the rainwater pH, since common air pollutants such as nitrogen oxides and sulfur dioxide, they trap heat in the air and they often affect the water chemistry as water is being held in the atmosphere as water vapor. So yeah, that's where they have their effect on water chemistry. And since there are quite a few factories around the city of Beloit, we concluded that the pollutants that those factories emit may have played a role in the lower pH of the rainwater. Overall, our original assumptions were proven correct. The stream water pH was higher at Big Hill in comparison to the high school, and the rainwater pH was lower than the streamwater pH at both locations. This project could potentially act as a gateway to another project about air quality, since we assumed that the air quality had an effect on the water pH levels. So a separate project studying maybe the air quality in Beloit in different locations, and then looking at the differences in rainwater pH there. I think that would be a really interesting project. And our research could potentially aid our community as well, since marine and aquatic organisms typically need a pH around 8, but the stream water we tested was often in the 5 to 7 range. So that's kind of an indicator that our water quality is not nearly as high as it needs to be, or not nearly as good as it needs to be. So it sort of is a warning sign that we need to take some action to keep our water clean. So that would include like trying not to pollute the river with all kinds of garbage, basically just keeping our river clean, and also a potential research project on air quality that could definitely aid our community because obviously it's the air we breathe, and if it's full of pollutants and it's lowering pH of rainwater so greatly, that probably means that there's an issue. So yeah, those are definitely some potential things that this research could help us figure some things out about. And then I would also like to make sure to acknowledge everyone that has really, really helped along the way, because this project would not have been possible without all the help that we got. We, Kate and I, we would like to thank the National Science Foundation for the funding that we received, Michael Notaro at the UW-Madison Nelson Institute Center for Climatic Research, Darien Becker at the Welty Environmental Center for logistical support and field assistance, Heidi Andre for introducing us both to environmental science, and Justin Johnson for logistical support and field assistance, and Kayala Eaton and Lauren Slatter for field assistance. Those were the two other interns at the Environmental Center, and they were super helpful in the process of data collection here. So yeah, that's about it. Thanks for watching.